Today we are doing day 3 of probability. We're going to talk about experimental probability and theoretical probability. As always, please complete your do now, watch this video, complete the Google form on experimental and theoretical probability, and then complete the reflection when you're done with the math for the day. Experimental probability is probability that is based on repeated trials of an experiment. So if you conduct an experiment, the outcomes are experimental probability. So the probability of the event is the number of times the event occurs over the total number of trials. So if you're flipping a coin, the number of times heads came up would be the experimental probability for your experiment, or the number of times tails came up. So if you look at the bar graph, it shows the results of rolling a number cube 50 times. So the outcomes of a number cube are 1, 2, 3, 4, and 5. You can roll a 1, a 2, a 3, a 4, a 5, and a 6. So we want to know what the experimental probability of rolling an odd number is. So if you look at the graph, the odd numbers are 1, 3, and 5. So we know they rolled the number cube 50 times. We want to know odd, so we look at 1. And 1 was 10 times. We look at 3, and 3 came out 8 times. And we look at 5, and because it's between the 10 and the 12, it came out 11 times. So 5 is 11, 3 is 8, and 1 is 10. So an odd number, we would add that up. So 10 plus 8 plus 11 is 29. So an odd number in this experiment came out 29 out of 50 times. Why? Because we rolled a number cube 50 times. So now we look at the next problem. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect to have in April? So the easiest way to do this is to set a proportion. If it rained 2 out of 12 times, we want to know how many times it would have rained in April. And April, by looking at the calendar, or you might know, has 30 days. So if it rains 2 out of every 12, remember how you solve a proportion. You can cross multiply, so you get 60 equals 12x. You divide by 12, it's a one-step equation, and x equals 5. So we would expect it to rain 5 days in April based on this experiment. So theoretical probability is what happens in a perfect world. So it's the ratio of the number of favorable outcomes to the number of possible outcomes. So if I have a coin, I know when flipping a coin, I can get heads or tails. If I were to flip this coin 50 times, in a perfect world, 25 out of 50 should be heads and 25 out of 50 should be tails. That is theoretically. Theoretically, it should be half the time heads, half the time tails. But we know if I were to conduct an experiment, that would not be the case. So let's look at this example. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So we need the favorable outcomes. In this case, the favorable outcomes E, O, or E, because I want a vowel. So there's 3 favorable. Total outcomes, there's 3, 6, 7. So the theoretical probability of choosing a vowel is 3/7. Theoretical probability of choosing an X, well, there's only one X, so that's the favorable outcome out of 7 letters. Now, if I were to choose 14 times, the chances of me getting an X, if it's 1/7 of the time, 1/7 of the 14, I should get an X twice, okay, theoretically. So like I just explained, this is another explanation. The theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6 the time. The wheel has 3 bobblehead sections. How many sections are on the wheel? So in this case, we know the theoretical probability of winning is 1/6. We have 3 bobblehead sections. We need to know the total sections. So the easiest way is to set a proportion, and we cross multiply and divide. So there are 18 sections on this wheel. 3 of them have bobbleheads. So now, the prize wheel was spun 540 times at a baseball game. About how many bobbleheads would you expect were won? So the probability of winning a bobblehead is 1/6 of the time. Now we're spinning the wheel 540 times. So we want to know bobbleheads should be won. And in this case, we set our of means multiply, so 1/6 of the 540. And we can reduce on the diagonal. 6 does go into 540 90 times. So we would expect 90 bobbleheads to be won. The last example, I want to put it all together for you, comparing theoretical and experimental probability. So the bar graph shows the results of rolling a number cube 300 times. We want to know the experimental probability of rolling an odd number. So this was our experiment, 300 times, that was the outcome. We want odd, so we're going to add 1, 3, and 5. So we add 48, 50, and 49. So you add 48, 50, and 49, and you get 147. So 147 times out of 300, experimentally, an odd number was rolled. And this can be reduced by 3. So 49 out of 100 times an odd number was rolled. Okay? So how does the experimental probability compare with the theoretical probability? Well, if you are rolling a number cube 300 times, every outcome should be equal. So we know there were 6 favorable outcomes, because it was a 1, 2, 3, 4, 5, and 6, right? We can have 6 outcomes. So out of the 300 times you rolled, every number theoretically should have come out an even amount of times. So if we divide it by 6, a 1 should have come out theoretically 50 times, a 2 50 times, a 3 50, a 4 50 times, a 5 50 times, and a 6 50 times. So theoretically, they all should have been 50 times. So theoretically, a 1, 3, and 5 should have come out 150 out of 300 times, or 1/2 of the time. Theoretically is what should have happened. Every number, every outcome on a spinner, every outcome on a coin should be equal theoretically. So as always, please try your best. If you need help, you can join Zoom at 10 a.m. Use the link you have in your email. If you need it, you can email me. Remember, experimental probability is the number of times the event occurred in an experiment over the number of trials. Theoretical should be what should have happened, the favorable outcomes over the possible outcomes. Okay? Experiment, what happens in the experiment. Theoretical should be what should occur. So one more time, if I have a spinner that has equal sections 1 through 4, theoretically, if I spin this 40 times, a 1 should come out 10 times, a 2 should come out 10 times, a 3 10 times, and a 4 10 times, because theoretically they all should come out an equal number of times. But if I were to take this spinner and do it, that might not be the case for experimental probability. If you need help, you can also email me. Have a great day.